Hello. Today we will go over a use case of designing data pipeline to get top 10 product views. You can use the similar design pattern, design approach for different business use cases, like getting the top 10 songs played for Spotify, or say getting the top 10 posts for Instagram, posts with most views for Instagram. So we'll design the pipeline using AWS cloud services. I will try to come up with 2 or 3 designs with given input requirements. I've made made up some requirements. We'll go through it soon. But basically, I'll try to use this requirements and try to come up with 2 or 3 designs. And while designing the pipeline, I'll go through my AWS console and we'll try to explain what each and every service do in the overall picture. So let's get started. So the use case is designing the pipeline to get the products which has highest number of views and will only get top 10 of them. Okay. And coming to the requirements, input is basically event message. So you can think of an logging service or a logging team that kind of generates an event whenever someone views look at a product. Like let's say if you're on your mobile app or on your browser, let's say you're scrolling or clicked on a product, logging service will generate an event and you will be subscribing to that event. And if I've just made up this event, you can think of something like this, like your event message will be a JSON with 4 attributes like event type. Here we're only worried about views. So let's say event type is an of type enum, and let's say view is one of them. As we are only concerned with view, we'll just filter those events with view as event type, and then user ID. What's the user ID of the person that looked at that product, clicked on that product, right? And then what's the product ID? And then what's the timestamp? So basically, this is the input side of things. We are getting the event message as input from the logging service, team. And here is how the input looks. And then there is this business logic. Basically, no matter how many times a person clicks on that product, you just have to consider it as one view. Let's say if I am user 1 to 3, I viewed that certain product like 1,000 times. Even though I looked at 1,000 times, I want to count, like the business wants to count it as one view. So that's the business logic. There is no like reasoning behind it. I've just made it up. And then on the output side, basically business is expecting to see a dashboard of top 10 product views for a particular day. Let's say tomorrow is March 3rd. They want to have the dashboard refreshed by 8 a.m. in the morning, 8 a.m. PST in the morning, and want to see the top 10 products with their names and category and all that stuff in a dashboard. Given these requirements, we'll try to come up with design using AWS services, and for that we'll use draw.io. And then I've also opened my AWS console. While designing it, I'll just go through each and every service and try to explain what's the purpose of it and how we can configure that service and all that stuff. So let's get started. Assume that your logging team logs those events as SNS events. So basically, this is maintained by your logging team. So we'll just do something like this. To back, and let's call it as like basically this is maintained by a logging team. Okay. They have this SNS topic, and you subscribe to that SNS topic as a data team. Okay, I'll just remove this just to be clear. So first step is that you want this dashboard. Let's start from backwards, right? So let's say we want to stay with all AWS services. So we'll pick Amazon QuickSight as our dashboarding tool. And then this pipeline, so what are the input data, has to be reflected in the dashboard at 8 a.m. in the morning, and it has to refresh once a day. So there are multiple ways to go about this this pipeline. So we'll start with one simple approach, and then we'll try to see if we can come up with a different design as well. Okay, so let's start from here. So we have SNS as input, and we want to display the data that refreshes once a day in QuickSight. Okay, so the first step that we can think of is that we can use a queue, Amazon queue, which is subscribed to SNS. It's like you can think of this as getting the messages from SNS continuously. Okay, so queue is subscribed to SNS, and if I want to quickly show you how do you like configure queue and stuff is I can show here. So like basically, queue is a messaging queue service. You can create the queue and give the queue name and all. There are certain parameters. You can go in detail and look at the parameters, what each parameter means in AWS documentation. You'll also specify the access policy, all that stuff. And once you create the queue, you can basically like subscribe to a particular SNS topic that you get from your logging service team. Okay, so once you have a queue configured, what it does is, let's say someone viewed a product, there is an SNS event that gets generated, and your queue automatically gets the JSON message, and it stores it. Queue is basically a simple queue where you can store a bunch of messages for a certain period of time. Okay, once you have the message in queue, let's say you use a Lambda. Lambda is a serverless compute platform where you basically can have this Lambda triggered on different settings. You can either trigger the Lambda, every time there is certain number of messages in your queue, or for a certain period of time. Let's say you can configure your Lambda to trigger whenever there are 10 messages in queue, or for every 10 seconds. Whatever happens first, the Lambda gets triggered. Okay, and then in Lambda, you'll write code to process the messages in your queue. In this Lambda, and then like basically Lambda lets you run the code without thinking about the servers. So maximum time limit of your Lambda, of any Lambda, is 15 minutes. So you would want to make sure that whatever the code that you write doesn't go over, like the execution time doesn't go over 15 minutes. Here, let's choose Python, and then what you'll basically do is I'll just like writing. Let's see if I can write this in over here. See if I can. Okay, I can run it, but I can write. But basically, let's see. Okay, I can write it here. So in your Lambda code, what you're basically doing is, for each message in your queue messages, which is basically list of JSON messages, you can do like data enrichment, data validation, or all that stuff, right? So here, what we'll do is, in our design, we'll just read the message and write it to Kinesis Firehouse. Okay. I'll show you why we do that and what are the alternatives. So just follow me for a bit, and then you'll get the point. Here, let's say our Lambda isn't doing much. We're just reading it from the queue and then writing it to Kinesis Data Firehouse. There are different services within Kinesis suite. Firehouse is one of them. What Firehouse does is it takes an input from like Firehouse only can take input from certain predefined sources and can only write the data to certain defined destinations. So if I go to the Kinesis Firehouse, it will make more sense for you. So here we are dealing with Firehouse. In Firehouse, you'll just put some data in, and the data gets, goes out. Instead of you directly writing to S3, or like what is the destination that you want to write to, you can use Firehouse as middleman for that will do the work of data transfer. Here, what we'll do is we'll do direct put, meaning in your Lambda, like whatever this function is, it does the put. Like basically, you'll get your Kinesis stream name, Firehouse name. Firehouse name, and then we'll do something like, but again, this is pseudocode just for you to have an idea. Um, so this is the put that we are talking about as input to the Firehouse. So you'll choose put, and as destination, you'll choose S3. Uh, and then you'll write the stream Firehouse name, and then do you want to do any record conversion, like format conversion? Example, in our case, our data is in JSON. Do you want to convert it to Parquet or RC? You can do that, or Firehouse does it automatically for you. So you can just enable that conversion and whatever the format that makes sense for you. Generally, you can just stick with Parquet for analytics and stuff. Parquet works fine. Instead of going with JSON, you can just do Parquet and it does the conversion for you automatically. And then you go through the config and click create Firehouse stream that will create the Kinesis Firehouse. And then we have created Firehouse to write the data to S3. So what Firehouse also does is it also creates a partitions. Not only does it convert the input JSON event from your queue and writes it to S3, it also does the partitioning. What partitioning is, let me show you an example, S3. Yeah, something like this, like Firehouse automatically does this. Like basically it creates a prefix. A prefix is nothing but subfolder in the main folder. And within year, it creates a month, and within month, it creates day, and within day, it creates hour, and within hour, it dumps the files. You can see that this is very helpful for our use case, because for our use case, we are trying to get the top 10 product views for a particular day, right? So whatever the end query engine is, it can only, it doesn't have to scan each and every partition. It can just go to the latest partition and then just read the do the metrics or aggregation on that folder only. So that way it will be optimized, like you don't have to read each and every subfolder within the data bucket. Okay, so now I think it probably made sense for you, right? We could probably directly write the input JSON to S3. Oops. You can directly do this as well, but the only problem is here you have to write the like you'll have to do the format conversion from JSON to Parquet yourself. Not only that, you'll have to create the partitions programmatically. But when you can bring in Firehouse into picture, Firehouse takes care of all that stuff. So you don't have to worry about any of it. So basically you'll put the JSON message into Firehouse. Firehouse kind of buffers the number of messages received. It does the format conversion. It also creates the partitions on S3 side. So that way, using Firehouse is very helpful. And then in order to query the data in S3 from QuickSight, you can do it using what's called Athena. Athena is basically SQL-like query engine, which lets you query the data in big data stores. Like S3 is like HDFS, right? So basically you cannot directly query the data in S3, correct? So for that, you will use what's called Athena. So Athena lets you, basically for you, whenever you write query in Athena, it looks like data is in regular database. You can just do something like select star from table where partition is equals to year is equal to 2024, month is March, and the date is so and so, and stuff like that. So that way like all the big data processing stuff is abstracted from you. Athena takes care of everything under the hood. If I want to show you how Athena looks like, so from user's perspective, Athena looks like it's like any other query editor. Once you create a catalog, once you'll basically have to create what's called glue table. So Glue is another ETL service where you can do big data programming. And then you can also create catalog or tables based on whatever the data that is in S3, right? Here you'll say add table and you see the select type of the source is S3, and you'll just point your table to the S3 bucket where you're writing your data to. So basically you're creating a table which points to S3 bucket, and then you are running the queries or Athena queries on top of the table. Like you'll do basically do something like select star from events table. Okay. And once you have that Athena table or Glue table created, your QuickSight can directly connect to the, like you can directly write that Athena query in Amazon QuickSight and have it refreshed once a day at 8 a.m. So you get the events from logging service team as SNS events. You have a queue that's subscribed to SNS, which stores the messages for, uh, uh, let's say for a day or two. But you don't even have to worry about it because you have your Lambda triggered every 10 seconds or for every 10 messages. Okay. And then your Lambda writes the data to to Firehose, and Firehose takes care of conversion and partition and writes to S3. And then you have a Glue table on top of S3. Then your Amazon QuickSight dashboard can be refreshed once a day. And then what are the logic that you put in? You can just do it in Athena. Like basically on a high level, what we are trying to do is get the product uh, products with top views, right? Top 10 products with most views. So what you'll simply do is like you'll do a simple SQL query like this. So basically, let's assume we have product ID. I think we have, yeah, we have product ID. And then we are also partitioning, right? Kinesis is taking care of partition. So we'll just do partition day is something like current day, date. Again, this is pseudocode. This probably doesn't work, but this should give you an idea. So here we'll do product ID and then just get the count product as product views. But one catch here is that we want to count the as per business logic, right? We want to no matter how many times a person clicks on product, we just want to do it as one view. So you'll just update your logic accordingly, right? Maybe you'll create a kind of CTE or a temp table where you'll just kind of dedupe the data, remove the duplicates for person or user ID, product ID combination, and then run this logic. Okay. This is how you can solve this problem, but there are different approaches to it, right? So if I go back to the design, here we are actually doing near real-time design, right? We are getting the messages, we are storing it in queue and triggering the Lambda every 10 seconds. Lambda writes the data. Let's say we are buffering the data for 1 minute and then writing it to S3. And the QuickSight dashboard, which uses Athena query, runs once a day. What are the query that we have built, right? It runs once a day. So everything from SNS to S3 is almost real time, right? Here we are spending 10 seconds or waiting 10 seconds. Here we're waiting 60 seconds. Let's call it 2 minutes, right? Overall end-to-end latency from SNS to S3 is 2 minutes max. But we are doing QuickSight refresh once a day. Right. So this is one approach, but you don't have to do the real-time approach, right? Because if your use case is to just have the dashboard refreshed once a day, then you don't even have to do this approach, right? Just let's go about doing the same thing using a different approach. Let's say you cannot change the input, right? Input is fixed. Your logging team has this SNS event, and you can just subscribe to SQS. Instead of using Lambda and triggering Lambda every 10 seconds, what we can do is we can use Glue. and have this glue run once every day, process the data, do the dedupe, what are the Athena query that we have done, do everything in Glue once a day, and write it to S3 bucket or even Redshift table, right? Because if you think about it, after this Glue transformation, for each day, you'll only have 10 rows because we are only worried about 10 products, right? Let's stick with S3 just to be, compare with the first design. Let's stick with S3 and then the remaining components still stay the same. So here you see, even though we are getting the events in real time, we are only processing it once a day. We are storing all the events in queue for a day, and then this triggering this glue job once a day, so that it reads all the how many ever events, right? Billion events, million events, no matter what, how many ever events. Your glue will read it, does the dedupe, does the aggregation, and writes it to S3. And then the same thing. Like here, your QuickSight just has to point to the latest partition, or even, QuickSight doesn't have to do, Athena doesn't have to do much of crunching here or aggregation here as it was doing previously. So you see the same problem can be solved differently with different approaches. Here we are kind of maintaining the near real-time latency. Here we break it. We're just reading it whenever, once a day. And you can also think of different approach, right? Um, let's say if you're working for a big company, it's a big tech company, and then your glue job has to process like billions of events, and deduping on billions and billions of events is very hard. So what you can probably do is, instead of doing all the dedupe and aggregation once a day, you can divide it hourly. So what I mean by that is, you'll still have the same source. You'll subscribe to that SNS topic, and then you will have the glue job that runs once an hour, right? And then kind of updates the final destination source. I'll just do it here, so this runs once an hour and everything else stays the same, right? Or what you can probably do is, you can dedupe the data once an hour and write it to a separate partition, meaning this is, think of this as like sub pipeline, right? So this glue job runs once every hour, and it puts the data into S3, like deduped data into S3. Let's say if I'm user 123, I've viewed a product like 1,000 times, but I'll only have one row in this uh, S3 partition. So so basically, Glue will create 24 partitions, right? We have 24 hours, so it creates 24 partitions. And let's say at the end of the day, we have another Glue job which reads the 24 partitions and then writes the data to, let's call it like final bucket, or destination bucket, or aggregated bucket. And then we'll have the same concept here. Something like this. So you see, there are like different approaches to solve the same problem. It depends on, how you want to do it, how robust you want to do it, or like how future proof you want to do it. Let's say, if the business comes back and if they want to make it near real time, maybe the first approach will will let you be more flexible, right? You'll just have to change the way Athena gets refreshed, right? This is kind of more robust, more like rigid architecture, where you're only running your glue job once a day. So it depends on different factors. Cost also comes into picture, but I just wanted to give you a sense of how to go about designing uh, or using different approaches to solve the same problem. Uh, Before closing the video, I also wanted to show you Glue, how Glue looks like. So in Glue, you can create ETL jobs. There are different ways to do it. You can use visual ETL, or you can just do the scripting part. So for this use case, what you'll want to do is create script and choose what are the engine. For big data, we use Spark. Glue is basically wrapper on top of Spark. And once you create the script, you can just write your logic here. Basically, you'll do something like data frame, is read from that S3 bucket, and then do dedupe, and then do aggregate, and then write the final top 10 product with top 10 views to the final S3 bucket. So this is how you would approach this use case of designing a pipeline to get top 10 product views. Hopefully this made sense to you. I just wanted to show you different approaches for solving one problem. Hopefully you have enjoyed it. Thank you. Thanks for watching. Bye.